Hi guys. Today I'm going to be talking a little bit about changing live audio with the web audio API. It's going to take you through some basics of the web audio API, and the end result will be that I will try to put some effects on the guitar here. It's going to be a live demo, so let's hope it works. It's a bit daring, but I have full confidence it will work. So let me introduce myself. My name is Bellen. I work for Made with Love, which is a small company from Belgium. You can find me on the internet as Samwegel, pretty much every site, Samwegel. If you are interested, this is a nice cartoon of me when I was a bit younger. And I really love guitar pedals. I'm not that good of a player. I like to play in my living room, annoy my cat or my neighbors, but I mostly like to put effects on pedals and just make noise. So, as a result, these pedals, they cost a lot, so I started into making them myself. These are a few of my pedals which I have at home. This just a lot more, but you don't have to see that. So I started to try to make them myself, which is some electronics and some schematics, and you have to have a bit of knowledge, but in the end it's just like puzzles coming together. And I was like, hey, if you can do this with electronic components, why not on the web? So I started using it. This is one of the pedals I built. And I was wondering, is it possible in the browser on the web with JavaScript, since we have this web audio API? Let's find out if it's possible. I think so. The first step you have to do is get the sound of your guitar into the browser. The first thing, if you want to use the web audio API, you create an audio context to work with. The second thing is you're going to get your input audio of your computer, usually that's your microphone. Now I've just hooked up my guitar with an extra device as if it is a microphone, but it's my guitar. And you just do get user media, you get back a stream of the audio, and you can work with it. This of course has been deprecated. Now it's navigated at media devices that get user media, but it only works in Firefox and Chrome. So if you want to have a little bit of cross-browser support, still use the old one, it still works. In the future you're going to have to switch to this API. And that's pretty much everything you have to do to get the sound of your guitar in the browser. You make from the stream you get from get user media, you create a media stream source with the audio context, and you connect it to your destination of your audio context, which is your speakers. Input, output, done. Step one, pretty easy. I'm going to demo after I've talked a bit about everything, because otherwise I will be using my guitar way too much. I don't like this in front of people, so. Step two, the hard part, add effects to the guitar sound. Of course, that was the main goal. Here my guitar on my computer, doing well, but I wanted to make some crazy sounds with it. So I started looking into some of the audio notes which are available in the web audio API. The first effect I'm going to build is pretty simple, a volume pedal. Most guitarists have a volume pedal to adjust the volume of their guitar. This can be done pretty easy. You have a thing called a gain node. You can create with audio context or create gain, set the gain value, which is usually an integer from 0 to float, from 0 to 1. So 0.5 is just 50% volume. You connect your input, which we got from get user media, to your gain node to your audio context destination. And you have a volume pedal which you can just adjust the volume. This is a visualization of just a fixed tone, and if you adjust the gain, you can see that an audio wave becomes more compact. If you make it bigger than 1, you see that it gets clipped on the top of the bottom. That's basically what a gain node does. It just adjusts the height of your waves, of your audio, of your sound waves. So that's it. Input, volume or gain node, output. Yay, we have a first effect. Second one is a distortion pedal, because I'm not that of a classical guitar player. I like to have a bit of a gnarly side on my sound, a bit of dark stuff. So you'll need a distortion or fuzz pedal or whatever. And the node we can use for that is a wave shaper node. Basically what a wave shaper node is, it is going to apply some math to create a curve and project that curve on your existing audio waves, so that it will just distort the audio waves you're making with the guitar. You do this very simple. Create a wave shaper, give some params, do some fancy math which nobody knows how to do, but there's a nice example on Stack Overflow. The link is in my presentation, I might be able to show it to you. Yeah, you have to basically calculate some curves which you project onto your wave. That's not the point of this presentation. That's if you have a PhD in math or so. But I can show you what it does, and I can let you hear later. But this is just a sine wave, a fixed tone, a basic clean tone, nothing really special. If you project the math onto it, you can see that the wave gets chopped off on the bottom and the top. This is really what this wave shaper is going to do. It's going to reshape your audio waves. Cool. We have a second effect. Input, wave shaper node, aka distortion pedal. Output, works fine. Let's get into some more fancy stuff. A delay pedal, which is something which I really love. You can do crazy stuff with that. And to help us create that, you have a delay node. A delay node is basically going to delay your sound for a fixed amount of time. The value you can say in delay time. And that's all it does. Instead of starting right away, it's going to wait, in this case 1 second, and then start your sound. Seems nice, but it's not something which is usable when you're playing continuous music. So we have to be a bit of creative and combine some audio nodes to create a delay effect. It looks like this. It's you split your chain at the first gain node. One just goes straight through, so you can adjust if you hear more of the delay sound or not. The second one is just the delay node, which goes to a gain node, lowers the volume, sends it back and forth, until the volume eventually becomes 0, so you don't hear it anymore. And you send it to the output. That's a delay effect. Sounds all cool, but when you hear it, amazing. The next one is a flanger pedal. That's even more exotic. Basically, that's a delay which is going to repeat your sound, but it's going to do this on up and down on a sine wave or whatever wave you choose. So it's going to be dynamic delay. The thing we use to create this dynamic wave is an oscillator node. You can create this, again, audio context.create oscillator nodes. In this case, you set the type, a sine wave, a square wave, triangle wave, sawtooth wave. These are all types of waves you can create, and then you set the frequency. I can show you what this does a little bit. This is a basic sine wave. Everybody has some basic math, so you know sine. Cool. If you choose for a square wave, you'll see the wave of your sound is totally different. Triangle wave, you guessed it, it's a triangle. Sawtooth, it's a little bit like a blade of saw. And then you can now see the difference in hertz. This is just basic 400 hertz. It's quite a big wave. If you choose 1000, you will see that they get more compact. 2000, even more compact. I don't know if you have sound. That's how it sounds. Basically, a sound is just a wave. And depending on the type and on the frequency, your sound changes. Enough with this stuff. And then, of course, flanger is a quite complicated pedal, so you have a lot of nodes working together. The thing to notice here is that instead of connecting the gain to the delay, we're just connecting it to the delay time parameter. So you don't only can connect audio nodes to other audio nodes, you can connect audio nodes to parameters of other audio nodes. So that, in this case, our delay time will go up and down together with the sine wave we create with the oscillator node. Pretty cool. You can do dynamic stuff with that. Nice. The last pedal I'm going to talk about is a reverb pedal, which is just something which adds some atmosphere to your sound, some echo or stuff like that. For that we use a convolver node. It's a bit more tricky to use that because you have to load an impulse response file, which is basically an empty audio file which holds characteristics of a room. Like this room is quite big, so there will be some echo. If you have a church, it's even bigger. If you have a small room, all these rooms have different audio characteristics. That's what's in this impulse response file. Then the convolver node will load this with this code and will project these characteristics onto your sound, which makes it sound like you are standing in a church, or you are standing in this room, or in your bathroom at home. Same stuff, you just split the channel. One goes to the reverb effect, another goes past it, so you can just have the real input of your guitar and the reverb, and mix them a bit together. And there are 1 million other nodes, which I'm not going to talk about because there's not that much time. One is an analyzer node, which you can use to analyze audio. You've all seen my first slide, which had the nice wave of the microphone in the room. That's just you analyze the frequency of the audio with that stuff and then draw it on the screen. A ubiquitous filter node is just to filter some frequencies, high filter, low pass filter, stuff like that. Channel splitter, channel merger node is to split, for example, from mono to stereo, or go from stereo to mono or to Dolby, whatever you want. Panner node is to change from left to right or front to back to position your sound in the space. Dynamics compressor node is to compress your sound so that you don't have really peaks in your audio waves, that they're all quiet into the same space, so that you don't have high volume nodes mixed with low volume nodes when you don't want it. Stuff like this. And this is all cool and stuff, but if you really want to use this on the web, you saw the schematics, you need a lot of nodes together to create these effects. So I started creating an audio effects library, which allows you to do this easier, I hope. It looks a bit like this. You just import distortion, you import delay, you chain them together, bam, works, hopefully. And this is all cool, if it really works. So let's try that. I made this little app on top of this audio library, and I have a guitar, and I'm quite nervous to play because there's some good guitar players in the room. Some really good guitar players in the room. But what this app does, it's just going to create some of these effects or stuff which I talked about earlier. We start with just creating an input, which is just going to take the input of my guitar, put it through the speakers, and if everything goes correct, you should hear through the speaker. You hear? Because I don't hear it. Okay, cool. Mission success. We have live audio. Now effects. We start with the volume one. It sounds like this. You can put it less or you can put it down. And it's less. That's what a volume pedal does. There's nothing fancy about that. But then we're going into the distortion one, which is going to make your guitar sound badass with just one click of a button. Stuff like this. You can hear that now it has a more of a rock metal vibe, whatever you want to call it. You can change some stuff which makes it even better. I'm not going to play fancy stuff because there's a little bit of latency and it's quite difficult to play, but I'm just going to demo it anyway. Next one is a delay. I talked about this. Let me switch these off because we don't need them at the moment. Standardly, you just have a delayed sound which is going to repeat. You can add the duration a bit longer so it keeps on repeating. At the speed a bit faster or slower. You can hear it goes quite fast at this moment. The wetness is just how much of delay you hear in combination with your sound. Then let's get exotic with the flanger, which is a basic. It's going to put a washing sound over your sound. If you hear there's this up and down going in the background, a dynamic kind of delay. Yeah, you can play around with this stuff. Put it on exotic settings, and you get crazy stuff. This is what I like to do, this kind of stuff. And you can combine them, of course, all together, which will get you really out of space. Last one is tremolo, which is just going to do this. This is a tremolo effect. This is going to add the volume dynamically on the sine wave again, so you'll have an up and down going volume. You might recognize this from movies as Kill Bill or stuff like this. Yeah, that's it. That's stuff I try to build just out of curiosity, and turns out it works quite well. I didn't show the reverb because I broke it earlier today and it's broken. But that one should be working next time you see me. Okay, cool, but what if you don't have your hands to control the mouse? Because I'm playing guitar, you need two hands, and usually you have pedals in front of your feet to turn on or turn off these effects. I tried to figure something out, and I built this thing right here. It's in front of this stand, you cannot see it probably. It looks like this, it just has some buttons which I can press with my feet. And it sends MIDI signals to the browser. I built this myself with a Tesla tool, which you can program in Node. It's JavaScript, we all can do that. It looks a bit like this. The Tesla tool doesn't support MIDI because there's no core MIDI or whatever on that stuff, so I had to be a bit of creative. I just open a socket to my laptop converts the signal to MIDI and sends it to the browser. So you could use a web MIDI interface, which exists, and this allows you to communicate with musical instruments or interfaces to the browser. It's quite easy, you just request MIDI access, you get a list of all the MIDI devices that your browser can see. You choose the one you want. This time I'm choosing 0, which is the first one, and this will let you control your browser. Let's try. This one I need a working Wi-Fi connection, so let's see if it works. I'm just going to press random buttons. Stuff you can see that I can just turn the fancy effect on and stuff. This is all just with my feet connecting over the Web MIDI API, which is a big fan of the Web Audio API. They go hand in hand. And that is about it for me. I have a few things on GitHub, my presentation is there as well. I'm not going to do a guitar demo unless Adrian wants to come up and fancy stuff. Yeah, that's it. Thank you.
Any questions for some?
Yeah.
So you showed these oscillator notes, right?
Yeah.
And you can select sines, saws, and
Exactly.
Can you also like build your own
Yep.
fancy?
You can also create your own waves, like you did with the wave shaper node. You calculate your own waves, and then you can just add a custom type to these oscillator nodes as well,
Cool.
if you want to go exotic or if you're very good in math. Yeah.
You said there was a delay, but what is the delay like?
The delay node or the delay effect, because
No,
it's...
the delay actually while playing, so can you actually really use that?
Ah, yeah, no, there is a little delay between me hitting the strings and you guys hearing the sound, because the browser is not that efficient. If you have to calculate, for example, the distortion curve, it has to do thousands of calculations every time the wave changes. So you add, it's a bit of a combination between how much audio nodes you use, your computer, how much calculations you do, that the sound will be a bit later, which makes it quite hard to play precisely, because what you hear is not what you're playing.
For example, if you have direct input output, then it's a real time.
It depends on your computer as well, and on probably which tabs you have open in your Chrome or whatever.
Yeah.
But that's quasi real time. Yeah.
So you
There's,
wouldn't be able to use this for live performance, probably.
excuse me?
Using this for live performance? wouldn't
No,
be-
this is just to play around. Maybe one day when browsers get good enough, we could use it. And the spec has changed this year, that there will be audio workers, so you can just ship off your audio stuff to a different thread. It will do this stuff, send it back to you. This will hopefully eliminate this this latency a bit, but no browser supports it, so I cannot really test it yet. It's new in the spec since this year. Hopefully soon Chrome and Firefox will do this. Yeah. All right. Somebody else?
You can't do search works with it, because then in search work you probably don't have audio workers.
Excuse me?
In search workers, you don't have audio workers.
No, because the audio workers, they really need the browser and the window object, navigator, I think, not window, and I don't know if you can access them service workers, no. That's why they invented audio workers. So we have to be a little bit patient, and then maybe we can make really cool stuff with this. We also have something called script processor nodes, which lets you really script everything. Those you can send to a different worker, but they're deprecated in favor of the audio workers. So it's not really worth the effort to look into it, to me at least, since they will be gone in a matter of years. When Safari has decided they don't like it anymore. Yeah. All right. Yeah.
Did you make songs with this already?
No. I just make noise. Yeah.
What is the device that
This thing,
converts?
it's just an external audio card on my computer, because if you would plug in a guitar directly into your computer, like a microphone, you would have even more latency, like 2 seconds or so. This eliminates that part of the latency. But it's nothing more than just an input device for a guitar. Yeah. Alright.
Okay, well,
Cool.
thank you, Sam. Thank you.